All right, we're going to talk about standard form of a quadratic function. So standard form is f of x equals ax squared plus bx plus c, where a, b, and c are real numbers and a does not equal 0. Okay, our vertex is going to be negative b over 2a for our x coordinate, and our y coordinate is just plugging that in. So it's f of negative b over 2a. Okay, so there's my vertex, negative b over 2a, comma, f of negative b over 2a. Our axis of symmetry is going to be x equals negative b over 2a, and our y-intercept is going to be 0 equal 0 comma c, right? If I plug in 0 here, I get c. So here we're going to look at graphing y equals x squared plus 2x plus 3. So the first thing I'm going to do is write down a, b, and c. So 1, 2, 3. Now I'm going to find the x-coordinate of my vertex. So my x-coordinate is going to be negative b over 2a, which is going to give me negative 2 over 2, which is negative 1. Okay, so I'm going to write that down there. My y-coordinate now is going to be plug in negative 1 into this. So I'm going to go negative 1 squared plus 2 times negative 1 plus 3. And I'm going to erase this a little bit. So this gives me 1 minus 2 plus 3, or 2. Okay, so there is my vertex. It's negative 1, 2. So I'm going to plot that. My axis of symmetry is x equals negative 1. So negative 1, 2, there's my vertex. That's my axis of symmetry right there, my vertical line. So that's where I'm going to mirror things apart. So now if I'm graphing this, what I'm going to do is I'm going to pick in, so I know I'm at negative 1. I could put 0 in. Well, 0, remember my y-intercept was 0c, so I have 0, 3. There's my y-intercept. Well, since this is symmetric, if I were to plug 2 in here, I should also get 3, right? 1 unit to the right is 3. 1 unit to the left has to be 3. We're going to check it just to make sure. So I have negative 2 quantity squared plus 2 times negative 2 plus 3. So negative 2 squared is 4 plus negative 4 plus 3 is 3. Now I'm going to connect those 3 points, and there's my graph. Okay. The next thing we're going to talk about is converting from standard form to vertex form. Okay. So one of the things is I do want to know what A, B, and C is again. So A is 2, B is 10, C is 7. The only reason I'm writing these down is just to get into the habit for later on when we're talking about like the quadratic formula and stuff like that. So if I want to know my x-coordinate, okay, so I'm going to go negative b over 2a. So I have negative 10 over 2 times 2, which is negative 10 over 4, which is negative 5 halves. So I now have a vertex of negative 5 halves, or 2.5. Just it kind of depends on how you want to write it, okay? Now if I'm going to find my y, I'm going to plug in negative 5 halves. So I'm going to go 2 times negative 2.5 squared plus 10 times negative 2.5 plus 7. This gives me 12.5 minus 25 plus 7. Just kind of double check that just to make sure. So okay, so here we get a grand total of negative 5.5. So negative 5.5. There's my x, there's my y. So now I can plug this into vertex form. So if you remember, vertex form is y equals a times x minus h squared plus k, where hk is my vertex. So y equals, well, I know a. A is 2. X minus 2.5, right? Negative 2.5 quantity squared minus plus negative 5.5. Now I'm going to simplify these down. So I get 2 comma k plus 2.5 quantity squared minus 5.5. So this kind of allows us to kind of see that we can find our vertex by doing negative b over 2a. Take that, plug it into my equation up here to find my y. Now I have my x and y. I already have my a from the beginning. So that's converting from standard form into vertex form. Now, remember the last thing is that understanding that our vertex is going to be our max or min. So there's going to be equations in there where they want to know the max. That is going to be our vertex or our min. That is going to be our vertex. So you're going to have to be able to find this vertex here by using the negative b over 2a and then taking that value and plugging it in.